Hello everybody. Today we're looking at lesson 2.8, solving inequalities in one variable. Our learning targets are to solve polynomial, rational, and other inequalities, not equations this time. And we're going to start out with a real life application. A lot of times manufacturing uses inequalities. For example, if we have a company that's making cardboard boxes out of a flat sheet of cardboard, think of how that's done. You're going to be cutting squares out of the corners, and then you're going to be folding up the leftover sides. Now, the big question is, how much area can you get out of a box? Because if you're a manufacturer, you want the maximum, or not area, you want the maximum volume for every box. We know volume is length times width times height. And once we cut out these squares, the length of my box will be 25 minus the x's on the side. The width of the box will be 20 minus 2x. And the height is going to be the x. When we fold it up, it's going to be this distance. Now, if we graph this on Desmos, or your graphing calculator, let's look at the graph that results. We have a cubic because we're going to have 3 x's multiplied together. And think through the logic of everything. Less than 0. If I look at points less than 0, well, that makes no sense because I can't cut out a box of negative width. Greater than 0, the volume is on the y-axis. The volume of my box is dependent on the size of the square I cut out, and it gets to a maximum volume of 820.5 inches squared. And that occurs when I cut out a box that's about the size of 3.68 inches. And then as that box gets bigger and bigger, the volume decreases until we would have no volume if we cut out a box that is 10 inches wide. And it doesn't even make sense, even though the equation's there, it doesn't even make sense to be able to cut out a box that's larger than that. So let's look at that. So if we have a box and we cut out our squares of 10 inches, well, we only have a 20-inch side, and there is no volume. Volume equals 0 because we can't have anything to fold up. And I think you can see what's going on here. If you're looking at the box, if we cut out a little square, we're going to have a flat box. We're going to get a taller box, until volume is going to max out. And then as you keep cutting out more and more, your box is going to be so skinny, the volume is going to get smaller again. And companies use this all the time. They want the maximum amount they can contain in a can or a box with as much material as possible because they want to reduce their cost. Now, it is often of value, therefore, to be able to determine when a polynomial gives positive values or when it gives negative values. Just like here, we were determining when this polynomial was positive. So first of all, let's start out, list everything you know about the polynomial 2x to the third minus 7x squared minus 10x plus 24. It's a cubic. It's a positive leading coefficient, so it's going to come up from the left and go up to the right. It's going to have possible zeros of a ratio of 1, 2, 3, 4, 6, 8, 12, or 24 over 1 and 2. Oh, that's a lot of zeros to check. But we can do it. If we plug in 1, I have 2 minus 7 minus 10 plus 24, it gives me 9. If I plug in negative 1, I'm going to have negative 2 minus 7 plus 10 plus 24, that's 25. If I plug in 2, 8 times 2 is 16, minus 28, minus 20 plus 24. I think I hit a wrong button. I'm trying it again. 2 to the third is 8 times 2 is 16. 7 times 4, minus 28. Negative 20 plus 24. I get negative 8, not a 0. Negative 2. Negative 16. Negative 28. Plus 20. Plus 24. Oh, there's my 0. So I have a 0 of negative 2. I have 2, negative 4, negative 11, 22, 12, negative 24, 0. So I can factor my cubic into x plus 2, 2x squared minus 11 plus 12. I'm going to try to factor that. What do I need? 11 in the middle? I kind of wrote that messy. So let's do 4 and 3, because then I have 8 plus 3, that's 11. 2 negatives should make it work. So I know my zeros are negative 2, 3 halves, and 4. So 4, 3 halves, negative 2. That's where my asymptotes are. Or not my asymptotes. My zeros. That's where my zeros are. And always good to get the intercept. Plug in a 0, get 24. That's pretty high up here. Up from the left, it's going to hit way up there at 24. I don't really know how deep it goes. I could check some points if I wanted to, but this is the general shape. Now looking at that, can we tell where is my polynomial positive? Well, here's my intervals again. This is negative 2. This is 3 halves. This is 4. It's positive from negative 2 to 3 halves. And from 4 to infinity, and it's negative from negative infinity to negative 2, and 3 halves to 4. We can use that same idea when we're solving inequalities. For example, I want to know when x to the third plus x is less than or equal to 4x squared minus 6. Well, one way you can do this is graph x to the third plus x. And you could graph 4x squared minus 6, find their intersection points, which is no easy feat, and then find the intervals where the blue is less than the pink. That would be here and here. That's a lot of work, especially for those intercepts. So let's look at a different method. We're going to find an equivalent inequality. We're going to move everything to one side. X to the third minus 4x squared plus x plus 6. And I'm going to set that less than or equal to 0. I have to find my zeros. Here's my possible zeros. Let's do f of 1. Well, I already know f of 1 is not going to work. 1 minus 4 plus 1 plus 6 is definitely not 0. Let's plug in negative 1. That would give me negative 1 minus 4 minus 1 plus 6. That gives me a 0. So 1 minus 4, 1, 6. My 0 is negative 1. Let's divide that out. So I'm going to have x plus 1, x squared minus 5x plus 6, less than or equal to 0. I'm hoping this factors. Oh, sure, it factors into negative 3, negative 2. And now I have what would be my zeros. So I'm looking at 2 is a 0, 3 is a 0, and negative 1 would be a 0. So what I want to do here is look at those intervals. And I want to see whether plugging a number in for those intervals will give us a positive or a negative value for my y. So anything less than 1, when I plug in, the first factor is going to be negative, the second's going to be negative, the third is going to be negative. It's going to be a negative times a negative times a negative, which gives me a negative overall. In between the intervals, let's do a darker green. In between the intervals, negative 1 and 2. Well, in between the interval negative 1 and 2, this is going to be a positive. Whoops. I hit the wrong one. This is going to be a positive. This is still going to be a negative. This right here is still going to be a negative. So I have a positive times a negative times a negative. Those y values will be positive. Now let's do another interval from 2 to 3. From 2 to 3, if I plug in a number in between 2 and 3, I'm going to have a positive, a negative, and a positive. That's going to give me a negative overall when you multiply them. And the last one, if I plug in anything bigger than 3, I'm going to get a positive, positive, and a positive. And that's a positive overall. So my big question was, well, when is this polynomial less than 0? When is it negative? From negative infinity to negative 1. And it's equal to, less than or equal to, so I can use the bracket. And from 2 to 3. Those are the values. Those are the range of values that would cause this inequality to be true. And remember, these are equivalent equalities. Let's try it with rational functions. List everything you know about this rational function. So let's do vertical asymptotes. 2x squared minus 5x minus 12. Where is that equal to 0?
When you get back, put it in the brush.
4 and 3.
Yes.
So if we do
Follow me to the gas station.
negative 4 and negative 3, that gives us a positive 12. Let's see if something else will work. Sorry, I have a noisy home. Let's do 6 and 2. That gives me 12 and 2. That's not going to work. Oh, I know what I was doing wrong. 4 and 3, we want it to be positive 3. Now I have negative 8x plus 3x to give me the negative 5. So my zeros are at negative 3 halves and 4. 1, 2, 3, 4. Negative 3 halves. That's where my zeros are. I also want to look at where x plus 1 equals 0. That's where x is negative 1. That's going to be another point we're going to have to look at. After that, here's my asymptote. Here's my other asymptote. Notice that my degree of the denominator is bigger than the degree of the numerator. So as those x values get larger and larger, that whole fraction is going to go to 0. So I have an asymptote at y equals 0. And now what I want to do is just look at the values in between. And we won't spend a lot of time on this. We'll just, if we plug in 0, I'm going to get negative 1 over 12. So I get negative 1/12 right here. If I were to plug in 2, I'm going to get 3 over 8 minus 10 minus 12 would be negative 14. And my function always hugs my asymptotes. If you wanted to, you could get more points. I want to check a value 4 on the right and 4 on the left. So let's do f of negative 2. So if I plug in negative 2, that gives me negative 2 plus 1. On the bottom, that would give me 8 plus 10 minus 12, which is going to be negative 18 minus 12, negative 1/6. Again, you could get more points if you want to shape out that curve. And if I get something on the right side of the asymptote, x equals 4, I would have 6. 2 times 5 squared, 2 times 25 is 50, minus 25 minus 12. So that's going to be, what is that, 6/13? So that tells me it's on top. So a refresher on how to graph rationals. Now, where is my graph above the x-axis? Where is it below? Well, it's above between the interval negative 3 half and negative 1. It's also above from 4 to infinity. It's below from negative infinity to negative 3 halves, and from negative 1 to 4. This is the skill we use when we solve inequalities. All we're asking is, where do our graphs fall above and below? But we don't always have to graph it. For example, in number 4, I want to know when the graph 5 over x plus 3 is less than 3 over 1 minus x. To do this, we first want to simplify things. And to simplify things, we put everything on one side of the equal sign. Now, some of you are probably thinking, why can't I cross multiply? The problem with cross multiplying here is we don't know if x is negative or not. So we wouldn't know if we could flip the inequality or not. Then we go ahead and we find a common denominator. So we have 5x, 5 minus 5x minus 3x minus 9, x plus 3, 1 minus x, less than 0. So I have negative 8x minus 4 over x plus 3 1 minus x less than 0. And at this point, we would know, we would have asymptotes at 1, 2, 3. And we would have a problem at x equals 1. And also, where is our numerator equal to 0? At x equals 1/2. Let me check my points here. Are these all right? 5x minus 5 minus 3x minus 9. I have negative 8x minus 4. Oh, it's going to be negative 1/2. So I add the 4 and divide by negative 8. And now I simply want to check each of the intervals to see whether my rational function would be positive or negative. So anything below negative 1/2, for example, if I plug in negative 1 in for x is going to give me a positive numerator, and it's going to give me a positive and then a negative in the denominator. So my values are all going to be negative. In between negative 1/2 and, what was this value again? And 1. So let's think of 0. It's going to give me a negative in the numerator and a positive and a negative in the denominator. Okay, when they're both the same, that makes me look. Did I make a mistake here? So if I put in anything less than negative 1/2, I did so like negative 1. That's going to give me a positive. If I go I know what I did wrong. 1, 2. So sorry about this. Let's fix this. Where are my zeros? Where are my problem spots? 1 is one of them, but it's negative 3. This 0 is negative 3. I had positive 3. And 1/2. So these are the places I'm going to have asymptotes, or I'm going to cross the x-axis. All right, now let's look at the intervals again. Sorry about that. Let's look at the intervals again. Anything less than 3, less than negative 3. If it's less than negative 3, my numerator is going to be positive. 8 times negative 3 is positive 24 minus 4. In the denominator, I am going to have anything less than negative 3 plus 3 is going to give me a negative. And 1 minus anything less than 3 is going to give me a positive. I'm going to have negative values overall. In the interval between negative 3 and 1/2, so let's think of like negative 1. Again, my numerator is going to be positive. My denominator is going to have like negative 1 plus 3 would be positive, and 1 minus any negative number would be positive. I'm going to have positive values. If I look in between the interval negative 1/2 and 1, so for example 0, I'm going to have a negative number in the numerator, and I'm going to have a positive and a positive in the denominator, giving my overall y values a negative sign. And then finally, for any number greater than 1, I'm going to have negative in the numerator. I'm going to have a positive and a positive in the denominator. Oh, let's look here. Something's looking up. I'm going to have a negative in the numerator And I'm going to have a positive number here. Oh, and I'm subtracting a larger number than 1. So that's going to be a negative, which is going to give me positive values overall. So there are the y values for the various intervals. And when I look at that, and the question asks me, when is 5 over x minus 3 less than 3 over 1 minus x, the equivalent inequality was, down here. So when are those values negative? Well, from negative infinity to negative 3, and here, which was negative 1/2 to 1. So we don't have to go out and graph the whole thing. We could if we wanted to. We're just interested in what is happening to the y values in between those key places, in between the spaces that would have an asymptote or where it would have an x-intercept. That's the intervals we want to look at. Now, it doesn't have to be a rational function. It doesn't have to be a polynomial. It doesn't have to be any sort of function we've seen before. It can be some crazy functions, like this one right here. Well, first of all, we know x has to be greater than or equal to negative 1. So we know that for the interval, everything left to negative 1, the function is undefined. But we want to find out on the other side of negative 1, when is my function positive? When is it over the x-axis? And so again, we got to find our key points. So where are things going to go? When are they going to cross the x-axis, or is there an asymptote? Well, there's no asymptotes for this function. There's no denominator, but we know when x is 3, then we are going to cross the x-axis. So we want to be looking at the interval between negative 1 and 3 and greater than 3. So between negative 1 and 3, when we subtract 3 from that number, we're going to get a negative value, but the square root is always positive, so these values are going to be negative. And to the right of 3, for any values greater than 3, when we subtract 3, we get a positive, and the square root is always a positive, so we're going to get positive y values. So when is it this function is positive? And it is greater than or equal to, so we can use the bracket, it's from 3 to infinity. And now just looking at that, I have no idea what this function looks like. It kind of makes me want to go look. So I did. I actually plugged it in, because when I first saw it, I was like, I don't know what it looks like. So let's plug it in. X minus 3 and square root of, I believe it was x plus 1. .5. And was this what our function looked like? X minus 3, square root of x plus 1. Let's fix my scale. Let's go from negative 2 to back to something reasonable. No, I got 1,000. How did I do that? Oh, I didn't do the y-axis. Let's do 20. Let's do negative 2. There we go. And there's my function. And sure enough, over the value 3, it's positive. It has positive y values. Okay, so that concludes this chapter. That concludes this section. Graphing inequalities, it just takes, it's pretty much a summary of everything we've done. go ahead, graph the function, and then you're looking at when that function is above the x-axis or when it's below the x-axis to give you the intervals and when the y values are positive or the y values are negative.